Given triangle ABC where C is the right angle, suppose cosine of A is 3/9. So we are going to draw a right triangle like we did last time. C is the right angle. I'll call that A and B. So the hypotenuse is always the hypotenuse, right? It's always that longest side. And we're given cosine. So remember, cosine of some angle is adjacent over hypotenuse. So if we're looking at angle A, this side is the adjacent, and then all the way across would be the opposite. So we're actually given these side lengths, 3 and 9. So this is 3 and this is 9. And then we will be finding CB or BC. We'll call that X. But let's start with the angle just because it's a quick operation. We're given cosine as 3/9. To find angle A, to get A by itself, we take the opposite of cosine, which is inverse cosine. So I'm going to take inverse cosine to both the left and right of the equation. And what happens is the cosine and cosine inverse are opposite operations. They equal 1, so we're just left with A is cosine inverse of 3/9. So that's what goes in the calculator. I'm going to open my functions. Here's my inverse trig, 3/9, and round to 2 decimal places, so 70.53. And then you want to enter degrees. So DEG. Okay, to get angle B, we subtract that from 90. So 19.47. The two other angles in the triangle, the opposite ones, those add to 90, and then you add the right angle, and you get 180. Okay, last step, you got some options. You can use Pythagorean theorem, or you can use trig. So I'm going to use trig and do opposite over hypotenuse. So I'm going to do sine of A equals x/9, and then times both sides by 9 to get x by itself. And that just goes in the calculator. So 9 times, and I'm just going to type sine, S-I-N, of 70.53, which is 8.49 rounded. Let's see what they did. They used Pythagorean theorem. It's totally fine.